For our next standard, in lesson 1.5, we want to be able to solve inequalities with one variable. So another challenge might be that we need to actually write the inequality. We have a taxi cab charging $1.75 right off the bat. That has nothing to do with how far you go. It's just a flat rate. In addition, that might give us a hint that we have a plus sign coming on. We have 65 cents per mile. Katie has no more than $10 to spend on a ride. So we don't know how far she's going to go. That question's coming up here in the second bullet. But when we don't know how far she's riding, we'll call that X, how many miles. So we do know they're going to charge 0.65 for every mile X that she travels. We also know we could say she has $10 to spend, and we could put an equal sign in there. But she has no more than $10. She can spend all of her 10, but she's hoping to have a little money left over. So we're going to use this symbol called less than or equal to. This tells us that she has to follow this price line with a $1.75 fee and 65 cents a mile to stay below or equal to $10. This right here is creating an inequality, much like we used to create an equation. The difference is we have these inequality or gator symbols, if you've remembered them that way before. So we've done the first part. We've written the inequality. Now we're going to solve it. It's really no different if you think of drawing your line down the center. We're going to subtract the 1.75 from both sides to be able to get our X value alone. So 10 minus $1.75 would be $8.25. And I'm going to bring down my inequality, less than or equal to, and my 0.65x. Finally, I'll divide by 0.65 on both sides. And it comes out to x being less than or equal to 12.7. That means she can't go more than 12.7 miles, or she'll exceed her $10 budget. Sometimes when we solve these inequalities, there can be some interesting things that take place. So let's solve a couple of these. Here we have our x in a fraction, which can look a little daunting. We're going to go draw our line and solve it just the same. So instead of subtract 3, I'm going to add 3 to both sides. Bring down my x over 3, and remember a negative 3 plus a positive 3 is gone. Leave my alligator, or my inequality, if you will, and negative 6 plus 3 is negative 3. My next step would be to multiply by 3, since dividing by 3 is going on. So if I multiply by 3, I get x is less than or equal to negative 9. Now notice that we did some subtraction or addition and multiplication. That's all fair and easy. Here we have, I'm going to add 2 to both sides, and I get negative b is greater than 10. We don't like negative variables. So in order to handle that, we could divide by a negative 1. But with inequalities, if you ever divided by a negative, your inequality needs to flip. So we can flip our inequality and have 10 divided by negative 1 be negative 10, but in the process, our inequality has changed. Now this says b is less than negative 10. If I were to put that on a number line, we would have an open circle, because b has to be smaller than negative 10, and we would shade to the left. I often remember it that if the letter is on the left, your b, and your arrow says less than or points to the left, your shading will also point that way. The circle is open because it cannot be equal to. If we come back to graphing the solution to the first one on a number line, at negative 9 we would actually have a full circle. And all x values must be equal, that's why it's filled in, or less than negative 9. So again, we would shade down to our left. Let's try one more. If we want to add 4 to both sides, we would drop down our inequality and we'd have negative 11x is greater than negative 11. Here comes that tricky part of if we divide by negative 11 and you have an inequality. Negative 11 divided by negative 11 is a positive 1, and my x stays here, but dividing by a negative changes the inequality. So instead of greater than, it now becomes less than. And if I put that on a number line with my 1, it's going to have an open circle because it doesn't have equal to. And this says x is less than -1. That means it's going to be below -1. Also note that the arrow here is pointing the same way the inequality is, as long as your variable is on the left side.